By 2026, the workflows that built your business are the same ones currently cracking it apart. Manual data processing simply cannot support modern enterprise scale. The market is pricing this reality directly. Right now, roles limited to Excel command an average of £39,000. Add Python to that same functional role, and the average jumps to $72,000. Take a look at this scorecard. Operations buckle when spreadsheets lock up past 1,000,000 rows. Project managers manually track Jira, and leadership commits budgets based entirely on gut feeling. Most look to Python to bridge these gaps, but face a new hurdle: over 500,000 packages. Guessing which library to use accumulates technical debt, introduces vulnerabilities, and causes implementations to fail. So we aren't here to debate whether you should adopt Python. We need to identify exactly which Python stack aligns with your specific operational bottleneck. By the end of this breakdown, you will know exactly which libraries you need to adopt for your role, and more importantly, which ones you can completely ignore. Keep in mind, Python won't fix a flawed business strategy. It will simply expose and mathematically scale the operational logic you already have in place. Let's look at the data professional. The core friction here is volume. When you try to force millions of rows through Excel, the software crashes and your macros become incredibly fragile. The fix is transitioning to standalone Python, specifically relying on libraries like Pandas and NumPy. This matrix lays out the difference. Microsoft integrated Python into Excel, but it cannot process true enterprise data volumes. Standalone Python is built for that scale. Pandas processes millions of rows in seconds, and by writing code, your error rate drops to near zero. There is a trade-off here. Booting up a Python environment to run a quick sum on 50 rows of sales data is severe overkill. You are giving up the immediate visual scratchpad utility that a spreadsheet offers. Pandas provides the necessary infrastructure for scale. You transition to it when your data volume exceeds what a visual interface can reliably display. Next is product operations. The bottleneck is human bandwidth. Product managers burn hundreds of hours manually pulling Jira status updates and typing stakeholder reports. This requires the ops stack. By using the Python Jira library alongside the requests library, you can automate that entire retrieval process. Instead of manually clicking through tickets, your script pulls the exact data, standardizes it, and sends the communication out. You immediately reclaim those hours. But look at the data flow. If your automated script hits the Jira API too fast, requests stack up, the connection chokes, and the pipeline fails. You also introduce a security requirement. Scripts need access tokens to pull data safely. These workflows are also dependent on outside platforms. If Jira changes their API structure tomorrow, your custom script breaks immediately. Product operations automation is a strict exchange. You trade the cost of manual human labor for the technical maintenance of third-party API connections. Finally, let's look at strategic leadership. The pain point is risk. Executives frequently commit massive resources based on intuition rather than quantifiable historical ROI. This is where strategic AI comes in. You feed historical business data, budgets, durations, and department types into classical machine learning libraries like scikit-learn. Using linear regression modeling, the library processes those past outcomes to find the exact mathematical patterns of your successes and failures. This predictive ROI heat map compares project duration against department type. Yellow zones show high profit projections. Dark areas indicate guaranteed losses. But notice the boundaries. The model cannot predict unprecedented, black swan events with no historical data. It is also bound by the law of garbage in, garbage out. If your historical data is messy or inaccurate, your predictions will be exactly the same. Scikit-learn does not give you a crystal ball. It mathematically projects the hygiene and accuracy of your past decisions into your future. Python acts as a force multiplier for your existing operations, but only when you apply it to a specific high-friction bottleneck. This decision flowchart maps exactly where you need to start. If your primary bottleneck is data volume and fragile spreadsheets, you need the analytics stack. Focus your training on Pandas and NumPy to process data at scale. If your bottleneck is manual workflow coordination and endless status updates, you adopt the ops stack. Learn API interaction with requests and Jira. And if you are facing strategic blind spots, you utilize the forecasting stack, relying on scikit-learn to model your historical data. But there is a strict sequence to this implementation. You must never start by building advanced machine learning models. The analytics and ops stacks have to be mastered first. That is the only way to ensure the underlying data feeding your forecasting models is clean, properly paginated, and secure. You cannot build a reliable AI penthouse without first laying down a flawless, automated data pipeline for a foundation.